Okay, so this is the new syllabus of your extended math. Yeah, and this is the very first past year and I think the only past year paper we have right now. A lot of students feedback to me that this paper is hard. It is not hard. It's because you haven't seen any past year papers related to this. This might be the very first time you see this kind of format. Okay, so at least you have a past year paper to deal with. Your seniors going through the new syllabus who took this exam in Feb-March, they have nothing to prepare them for. Okay. Anyway, we're gonna prepare this, and at the end of the review, I will highlight to you all what things to take note of, right? So you all can prepare and anticipate for when you take the exam. Okay, this is non-card paper, and I'll also be highlighting some interesting feedback from the examiner's report. Okay, question 1. Oranges cost 220 rupees per kg. Work out the cost of 9 kg of these oranges. This is very simple math. 220 times 9. Usually this only comes out in core paper, but this is non-cut, they put in extended already. Okay, 0 times 9 is 0. 2 times 9 is 18. 2 times 9 is 18 plus 1 is 19. So this is just testing basically on your whether you can do multiplication. Okay, 1 mark, free. Next, Aryan goes on a journey. He leaves home at 11:40 and arrives at 14:18. Now, depending on how you learn how to calculate time, there are generally two ways to calculate time. Okay, so for example, here, my way is just to take end time minus start time. Okay, so 18 cannot minus 40, so I borrow from the hour. So this becomes 13, this becomes 78. 78 minus 40 is 38 minutes. 13 hours minus 11 is 2 hours. So the duration is 2 hours and 38 minutes. Okay, some students in primary school, they learn it using the timeline. So 11:40, 14:18. Okay, so we go to the nearest hour first. So 20 minutes, we go to 12. Okay, then we go to the nearest hour again. So we go 14:00, and this is 2 hours. Then we go to the time plus 18. So we do 20 minutes plus 2 hours plus 80 minutes. Same thing, the duration is 2 hours and 38 minutes. Okay, now what you can anticipate to come out is what I call cross-day calculation. Okay, so you can anticipate questions something like this, right? You start at 11:40, not 11:40, 11:40 p.m., yes. And then you arrive at a place at 2:30 a.m. Okay, how do you count the duration? Okay, so this one you can also prepare for, like, just if you are not good or you're not confident in calculating all this, it's time for you to go and practice. Okay, non-cut paper demands that you also remember the things you learned in primary school. Okay, next one, question 3. Examiner's report say most students found this challenging. That means most students cannot get this lah. Okay, quadrilateral has one line of symmetry. Okay, in your syllabus, it will be helpful to recall the kinds of quadrilateral you'll learn, right? The special quadrilaterals. There's a square, rectangle, trapezium, parallelogram, rhombus, and kite. If you can, try and recall all these. These are the only quadrilaterals that you will do. Okay, and I think this is the only quadrilaterals, special quadrilaterals, period. Okay, so one line of symmetry, definitely not a square, definitely not rectangle. Okay, definitely not trapezium, because trapezium is not guaranteed symmetrical. Okay, interesting fact, parallelograms have 0 line of symmetry. It has no line of symmetry. Okay, rhombus as well. Okay, so rhombus no. Okay, next, you're basically done here, by the way. it's a kite, right? So it's a kite. Yeah, it could be a trapezium. It could be a trapezium if your trapezium is isosceles, right? If it's isosceles trapezium, then there's one line of symmetry. Okay, so the second condition comes, diagonals of quadrilateral cross at right angles. So there are only a few shapes which have this property. It's basically the kite, square, and rhombus. Their diagonals will bisect each other at 90 degrees. So square is like this. This will be 90. Rhombus also will cross at 90. Kite will also cross at 90. Okay, so the shape is a kite. Okay, let's move on. Okay, basic algebra, question 4. Yeah, this was generally quite easy for a lot of students. So we just basically substitute in the values. So V equals 4 times 10 times negative 3 squared. Okay, so 4 times 10 is 40, negative 3 squared is 9, and 40 times 9 is 360. Okay, common mistake is here, when you all sub this in, basically if you have practiced, you probably won't have this issue. But some students would just do this and then calculate this to be 9, negative 9, sorry. Negative 9 is wrong, yeah? Okay, find the positive value of P when V equals 3200 and M equals 2. Same thing, we substitute in the values. So 3200 equals 4 times 2 times P squared. Okay, so 8P squared equals 3200, and I divide 8 on both sides. Okay, so P squared equals 400. Then the square root of 400 is 20. It's actually plus minus 20, but they only want the positive value, so we just take the positive value. Okay. Question. Yeah, see, a lot, like the first 5 questions, you all actually see primary school questions already. Like question 1, 2, 3, and 5 are primary school questions, by the way. Write these lengths in order of size, starting with the smallest. This test on your prefix. And thankfully, they only test you on the easy prefixes, right? They don't test you on micro, milli, giga, all those stuff. Okay. So the trick is to convert them into the same unit. So we're going to change everything to cm. I believe this is easier for everyone. Okay. So meters to cm, we times 100. So this is 3 cm. Okay. mm to cm, we times 10. So this is 320 cm. Sorry. Divide 10. My bad. Divide 10. So this is 3.2 cm. Km to cm, we times 100,000. Okay, so we move our decimal place 1, 2, 3, 4, 5. This is 20 cm. Okay, so the smallest is 2.9 cm. Second is 3 cm. Right back down the original one. 0.03 meter, 32 mm, 0.00002 km. Okay. Okay, I'm not sure if they will penalize you if you all write it in in your converted units format. Let me check now. Okay, yeah, I'm not sure. I'm not sure whether they give you marks, but just generally write back down using the notation that they've given you. Okay, report says that most students incorrectly converted this. Okay, so prefixes, actually it's in your syllabus, you all need to remember this. But you can gamble that they don't come out. Okay, the prefixes are your pico, nano, micro, milli, kilo, Peter and Mary miss kissing, mega, giga, tera. And so these prefixes have this order, this 10 power negative 12, 10 power negative 9, 10 power negative 6, 10 power negative 3, 10 cube, 10 power 6, 10 power 9, 10 power 12. Again, if you're in the mood to go and study, please revise this, or else you can actually gamble that they don't come out. Even if they do, it's like 1 mark, so you can afford to throw it. Anyway, I shouldn't be telling you this. Okay, next one. What, 3 marks? Again, okay, until question 6, the first 6 questions, 5 out of 6 are still primary math questions. Work out the area of the trapezium. There are 2 ways of doing this. One, you just memorize the area of trapezium. Wait, is it in the formula sheet? Let's check. Oh, it's not in the formula sheet. Okay, too bad. Okay, one is you remember the formula for the area of trapezium. So it's just half times A plus B, the sum of the parallel sides, times H, the height of the triangle. The height of the trapezium. So if you remember the formula, it's just half times the height times the sum of the parallel sides. Okay, so this is half times 8 times 24. This is 96. Okay, another way is touch wood, you forget how to calculate the area of trapezium. You can actually cut this in a triangle and a rectangle. And this works for all trapeziums, by the way. Okay, so this is 6. So you can calculate the area of the triangle here, which is half 6, the base is 8. Okay, and this is U passes about 24. Then you calculate the area of the rectangle here. So 9 times 8, 72, and then you add them up. Okay, both methods work. If you're 16, 17-year-old and you don't know the area of the trapezium, gotta help you. Okay. Primary schoolers do this. Okay, secondary schoolers do this, huh? Okay, question 7, 3 marks. Write down the inequality of x represented by the number line. Okay, hollow dot means does not include. Solid dot means include. So here is just -3, x, 4. Okay. Yeah, not much to say about this. Let's move on. Question 8. Priyanka plays a game in which she can win, lose, or draw. The table shows the probability of her winning or losing a game. Complete the table. Okay, so again, simple concept of probability. Mutually exclusive events add up to 1. So to find the probability that should get a draw, just 1 minus 0.3 minus 0.25. So in the old syllabus, they will just give you 1 mark for this, right? In the new syllabus, why they give you 2 marks is because you need to actually calculate the decimal and also write out your working. If you write this out, you touch wood, you calculate your decimal strongly, you still get 1 mark. Okay, so how do you calculate decimals? 1.00 minus 0.3. So this is 7 minus 0.25, 5, 4.0. So it's 0.45. Okay, next, Priyanka plays this game 120 times. Work out the expected number of games she wins. So expectation is just the number of trials times the probability of that event occurring. So it's 120 times 0.3. How do you deal with this decimal? 120 times 3 out of 10. Change it to fraction. Cancel, cancel. This is 36. Okay, let's move on. Yeah, and let me see the examiner's report. Okay. No problem with this. Okay, by writing each number correct to one significant figure, work out an estimate of D. Okay, this is a new kind of question that you all probably won't ever see before. Okay, my students, if you all need practice with this, let me know. I have like 30 questions on this. Okay, you want to round everything to one significant figure. So there are 3 numbers here. 1.95, round it to 1 SF is 2. 9.92, if you round it to 1 SF, is 10 squared. 8.07, round it to 1 SF, is 8. And this, they give you 3 marks. Very, very generous. Okay, so if you round everything correctly, they give you 1 mark. Then you evaluate this. Sorry. 10 squared is 100. 2 times 10 squared is 2 times 100. This 200 over 8. Okay, ready to get 2 marks. 200 divided by 8 is 25. Okay, if you cannot do this mentally, do your long division. Right. Okay, 25. Square root of 25 is just 5. So an estimate of D is 5. Okay, let's move on. Okay, this one is ratio. Okay, 3 regular polygons ABC meet a point. The interior angles of polygons are in ratio 3:5. Show that the polygon C has twice the number of sides as polygon B. Wow. Okay, how many marks is this? 5 marks. So to show that polygon C has twice the number of sides as polygon B, 2 ways to do this. We can actually use the formula for the interior angles, or we can just use exterior angles. Okay, I'll show you both ways, but let's just actually deduce their angles. Actually, you don't even need to, okay, there are so many ways to do this. I think the most straightforward way that most students will do is they will go and actually calculate the angles out directly. Okay, in fact, I'll do this first. Okay, so 3, 4, 5, the total units here is 3 plus 4 plus 5 is 12 units. So we can actually figure out each of the sides of the angles. Okay, A, A is 3 units, so A is 3 out of 12. Everything here add up to 360, yeah? So times 360. Okay, so this one cancel, 1, 4, 90. Okay, so polygon A is a square. Okay, polygon B is 4 units, so 4 out of 12 times 360. Okay, cancel 1, 3. This is 120. Okay, C is 5 out of 12 times 360. Cancel. Divide both by 12. This is 30. 30 times 5 is 150. Okay. Okay, next, we can, there's so many ways to do this. Okay, next, we can actually figure out the number of sides by using their interior angles lah. Okay, so we are just interested in B and C. We actually don't need A, so I'm just going to erase A. I don't know why I found it anyway. Okay, let me move this up. Oops. You know what, actually, exterior angle. Okay, let's do interior angle first lah. Okay, so we know that for n times, like, the formula for interior angle, I'll just write it here first, is n minus 2 times 180 divided by n. So this is the size of the interior angle of a regular polygon, where n is the number of sides. Okay, so for B, to find the number of sides, I just use the formula. Here, I just solve an equation. N, so 60n equals 360, n equals 6. Okay, then I substitute, not substitute. I just use the formula for C. Okay, then I just solve the equation again. Okay, 30n equals 360, which I get n equals 12. And basically you're done here. Because the number of sides for B is 6. The number of sides for C is 12. So you show that this is twice. Okay. Now another way is to use exterior angle. Okay, exterior angle, by definition, is 180 minus your interior angle. Okay, 180 minus interior angle. Okay, and another property, this one's very important, just try to remember, the exterior angle is 360 divided by the number of sides. So if you have a regular polygon, the exterior angle of the polygon is 360 divided by n. Okay, so let's say if you have a pentagon here, okay, your external angle is here, your interior angle is here, your external angle will be here. So to find the number of sides, right, you just take 360 divided by n. Same thing here, right? We find the exterior angle of B first. Exterior angle here is 180 minus 120, 60. Then for C is 180 minus 150 equals 30. Okay, then you can just take number of sides is 360 divided by the exterior angle, which is 6. Okay, same thing here. 360 divided by 30 and equals to 12. And again, you get the same result, right? The number of sides of polygon C is twice the number of sides of polygon B. So that's another way of doing it. Okay, in general, using exterior angle to solve questions related to the number of sides is always the more efficient way. Okay, so I think this is the, this is the most efficient, most easiest way to do it. Okay, let's move on. Sorry. Okay, this one I think you need to go portrait mode. Okay, a company sells items either in a website or in shops. The composite bar chart shows. Okay, this is the first time composite bar charts have actually come out in a very, very long time. Okay, I hope the interpretation of the chart is pretty straightforward. All right, the one that is shaded is the part where it's sold on website. The one that's not shaded is sold in your brick and mortar stores. Okay, in April, 17 of 20 of the company's sales was on the website. On the grid, draw the bar for April. Okay, so the percentage of sales, in your vertical axis is the percentage of sales. So the trick to do this is just to convert this into percentage. Okay, so 17 out of 20 is the same as times 5, 85 over 100. So that means 85% of the company sale is on the website. Okay, so I'll just draw it in. Let me get out my handy tool. 85. Oh, too thick. 85. So draw until here. Okay, then the rest I put in. Rest I put in here. Okay, then I shade in. Okay. In February, a company had sales of 3.5 million. Work out the value of the sales in shop in February. So we look at February first. Oops. Okay, so total sales. Total sales is 3.5 million. Okay, I want to work out the sales in shops. So shops is the one yellow color, the hollow one. Shops take up 40% of the total sales. Okay, shops take up 40% of the total sales. So I just take 3.5 times 40%. That is it. So 40% is 4 out of 10. Okay, 4 out of 10 I can simplify to 2 out of 5. Okay, again, depending on how you want to do your multiplication fraction, okay, you can actually simplify 3.5 and 5 first by dividing it by 5. So 3.5 divided by 5 is 0.7. This will be 1. 0.7 times 2 is 1.4. Just like that, they give you 3 marks. Also, just saying, this is also in primary school. So I'm not sure if it's in IG, but if you've done Singapore math, I think this is primary 5 or primary 6. They would have done it also. Okay, let's just move on. Okay, in May, the company had sales 6 million. In June, the company had sales 7.5 million. So find the percentage increase in sales from May to June. 3 marks. Okay, percentage increase. I said this many times to my students. If you have done if we have done the percentage increase decrease chapter, percentage increase or decrease is your increase or decrease. My handwriting sucks. Okay, I'm gonna write short form decrease over your original times 100%. Okay, so the increase is 7.5 minus 6 million. Okay, your original is 6 million because you start from me. Okay, times 100%. Okay, so this is 1.5 over 6 times 100%. Okay, now I find a pattern out in paper 2, a lot of decimals and fractions. They will assume that you know how to operate decimals and fractions really intuitively, really quickly. 1.5 and 6 can be shortened to 1:4. Okay, and 1/4 is 25%. Okay, so let's say you cannot do this. This is not intuitive to you, then you do it the long method. Okay, 1.5 over 6 times 100. So you take 1.5 times 100 first. So it's 150 divided by 6. Okay, then you do your long division. 150 divided by 6. Okay, 25%. Okay, next. In 2024, the company... Yeah, let me check. Okay, in 2024, the company had total sales of 52 million. This was an increase of 30% of the total sales in 2023. It's a very standard percentage question. So this is an increase of 30%. That means this is 130%. Okay, so 130% of 2023 is 52 mil. So I want to find 2023. I'm just finding 100% of 2023. Right, and yeah, you can just divide 1.3. If that's intuitive for you. Now, if you cannot, again, my advice for you is to go to 1% first. So you divide 130, then you go to 100 times 100%. Okay, so same thing here. Whatever you do to the left, you do to the right. So divide 130 times 100. Okay, this is a bit tricky because you don't have calculator. Okay, so we do 52. Oh, divide 130. Another tip. Divide 130 times 100 is the same as you divide 13. You divide 13 and times 10. It's the same thing, by the way. Okay, because the zeros just cancel out. So 52 divided by 13 is 4. 4 times 10 is 40. So your original amount is 40 million. Okay. Examiners report say that part D, this portion is challenging for most students. Okay. Yeah. And then they say some were able to set up the equation correctly, but they cannot operate. So basically, they actually screw up this red color portion. Okay, so percentage, right, throughout the years and even until the new syllabus, it's still consistently coming up. So percentage is still a very high return of investment chapter to go and revise and practice as well. Make sure you get it like solid. Okay, question 11 is actually a percentage question disguised as a statistics question. Let's move on. Okay, 12A, algebra. If you can't get this, I don't know what you're doing, especially if you're my student. Now, if you add a minus fraction, the denominator needs to be the same. So this one, common denominator for everything is actually, oh my gosh, 24. So this one times 6. Yeah, I go back to landscape first. Bigger. Okay, so this one times 6 times 3 times 2. So this is 6x over 24 plus 9x over 24 minus 2 times x plus 2 over 24. Okay, once the denominator is the same, I just combine my numerator. Okay, here, let me remind everyone here, when you combine fractions, add brackets. Okay, so here, if you don't know when to add, when not to add, just add, right? Add here. Here already have, so no problem. Okay, next expand. I can simplify these two first. This is 15x minus 2x minus 4. Remember, common mistake here when you expand signs, students will make mistakes. Negative 2 times positive 2 is negative 4. Divided by 24. This is 13x minus 4 over 24. 3 marks, 3. Okay, examiners report say fully correct answers were less common in this question. They have very flowery way to say that students suck. No idea. They say primarily because of inefficient methods or errors or sign errors. Very different ways to say that you're suck at it. Okay. Part B, factorize this. This is grouping. So I'm gonna factorize this portion here. Okay, common mistake here will be your signs. So we extract negative y out. This will be a plus for y. Okay, then I extract common factor. I'm gonna extract this out. Extract this out. Extract this out. These 3x is left, minus y is left. So that's it. This is only 1 mark. Wow. Okay, so you either get it or you don't. It's no sympathy at all. Let's move on. Geometry questions. Okay. This one is actually pretty straightforward as well. Okay. Believe me or not, it's just working formula. Okay, diagram shows a cylinder with a radius r and a height of 16 cm. A sphere has radius 3 cm. The volume of the cylinder is equal to the volume of sphere. You see a lack of sphere here? Draw it out. Okay. Okay, I have a sphere. Okay, the radius is 3 cm. Okay, they have the same volume. So basically, we just form two equations and equate them. And just like that, you get 4 marks. Okay, so volume of the cylinder is volume of cylinder. I'll write out a more flushed out working. Volume of cylinder is pi r square times height. This is also in your formula sheet. Okay, so the volume of a sphere is 4/3 pi r cubed. So r is 3 cubed. So you can actually just simplify this. Don't go and evaluate pi. This is a non-calc paper. It's a hint already. You don't need to evaluate pi. Okay, so these two are the same. So I write out first pi r square times 16 goes. Sorry. 4/3 pi r 3 cubed. Okay, the pi cancels out. Okay, then I just rewrite things. 3 cubed is 27, so this is 4/3 times 27. 4/3 times 27, I can simplify. This is 36. Okay, 9 times 4 is 36. Then I divide 16 on both sides. Okay, to get r squared equals 36/16. I can simplify this. This is bit brain fart. 36/16 is divided by 4. 9/4. Okay, so I can divide 4, divide 4. Simplify first. Okay, every time when you see like squares and you want to square root, make sure you simplify first before you go and square root. Okay, next you square both sides. Okay, so r is 3/2. See. Okay, move on. Yeah, what did the examiner say for question 13? Many candidates gave the correct answer to these questions. Wow. Okay. Interesting. Okay, question 14 is circle theorem. They want you to explain. Good. Let's go. Okay, change to portrait mode first. ABC is circle, blah, 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 tangent, blah, 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 blah. Okay. Find angle BCD. BCD, where's BCD? BCD is here. Okay, if you don't have practice with this chapter, you'll be like, what the hell is going on? But if you have a lot of practice, you can see immediately cyclic quadrilateral. Okay, so that means this is 180 minus 110, 70. Oh, 70 degrees. 70 degrees. Okay, so this 70 degrees. Okay, depending on wait, let me see. Okay, depending on what how you learn it in school, right? A few things, like not a few things, a few ways to explain this. One, we can just say the opposite angles of cyclic quadrilateral. Cyclic quadrilateral. Lateral. Add up to 180. Okay. You can also say these are opposite, sorry, angles in opposite segments. Okay. I read short form. Okay, honestly, I don't know whether they'll award you for full marks. Right. Award you full marks if you write short form. Okay, I don't care if you're particular. In fact, please write out the whole sentence, right? Don't write short form. Okay, find angle DBC. Where's DBC? DBC is here. How do I do this? Let's see. Angle DBC. No, give me a while. Cannot think right now. Oh, okay. Wow. It's actually not that easy to spot. Okay, so we have established that this is 70 degrees. Okay, what would be nice to have? I want to find this angle. It would be nice to have, what the hell, wait. What would be nice to have? Oh, it'd be nice to have this one here. Right, why? Because I'm looking at this triangle. Okay, if I have the red color angle, I can just take 180 minus the red angle and minus 70 to get my angle DBC. Okay, and observe that, see this arrow like the butterfly shape, right? So this angle and this angle are the same because they are angles in the same segment. Okay, now for IG, if they didn't ask you to explain, you actually don't need to write out the explanation. Okay, yeah, so you just take 180. But this one is 45, by the way. So 180 minus 45 minus 70 to get 65 degrees. Okay, there was a bit of a label. Let's move on. Next one is, oh, yeah. This is 70. This is 45. Okay, find angle DCG. DCG is this one here. It's 1 mark. Oh, alternate segment theorem. Okay, so I have a triangle here. Okay, alternate segment theorems are usually they usually occur when you have a tangent. Okay, so the trick is this angle in the circumference at the circumference here will be the same as this angle here, because this angle is facing this segment, and this angle is sort of in this segment here. So these are alternate segment theorems. So 65 degrees. Okay, they only give you 1 mark. Okay, so if they give you 2 marks and ask you to explain, you say 65 degrees. Why? Because it's an alternate segment theorem. Okay, let's move on. Vectors. Okay, point A has the coordinates -1, 4. That means I can, from here, I can deduce the direction vector of OA. This is -4, 1. Okay, to find OB, I'm going to use the transiting method again. OB is OA plus AB. I go from O to A, and then I transit through A, and I go from A to B. Okay, so, but here they given you BA. BA is the opposite of AB. You just flip the direction. So this will be 5, 12. Basically, you just take negative of that vector. Okay, so OA is -1, -4, 1, sorry. AB is 5, 12. So your resultant vector is 113. So the coordinates of B is 113. Okay, point C has the coordinates 5, -2. That means again OC is 5, -2. I want to find the vector CA. I can go from C to O and then O to A. CO is negative OC. So it's -5, 2 plus OA. OA is -4, 1. So this is -9, 3. Okay, EF equals 3BA. Find the magnitude of EF. Okay, so I can find EF first, the vector EF. Vector EF is 3BA. 3BA is times 3 of this. So -15, -36. Okay, the magnitude of EF is 15 square plus 36 square square root. So you're basically like doing Pythagoras theorem. Right? You know. Okay, the numbers is very big here. Is there a faster way of doing this? Let me see. Okay, actually, there's a shorter. Okay, if touch wood lah, you don't want to think so much, you just do it brute force. Okay, 15 square is 15 times 15. This is 225. 36 times 36. I also need to do this. I cannot, too big, too big. Okay, no point doing this. So a faster method is actually you don't multiply in. Okay, so you do 3, -5, -12. Okay, so the magnitude of EF will be 3 times the magnitude of -5, -12. Okay, 5, 12 is a Pythagorean triplet. So 5, 12 gives you 13. So this is 3 times 5 square plus 12 square. Okay, if you do a lot of Pythagoras theorem, you know 5, 12, 13. Okay, or else you can also do it manually. 5 square is 25. 12 square is 144. You add them up is 169. 169 square root is 30. This is 39. Okay, I gonna guess that most students didn't get this. Let me take a look at the report. Oh wait, more many candidates answer this correctly. Okay. Well, interesting. No, like the students actually don't struggle with vectors. Maybe because it's very recent. Okay. So on stem and leaf. Okay, stem and leaf diagram shows the mass of 13 packets. Worked out the interquartile range. Interquartile range, if you're dealing with discrete data, that means like this, right? You actually need to find the midpoint first. Okay, 13 packets, the middle is 6. Is it 6? 1, 2, 3, 4, 5, 6. No, the 7 one. So 1, 2, 3, 4, 5, 6, 7. So this is your median. This is your midpoint. Okay, then to find the interquartile range, you need the first quartile, the lower quartile, and the third quartile, the upper quartile. Okay, the first quartile is the middle of your middle group. Okay, the middle of your first group, sorry. So your first group is here. Oops. First group is here. Oops. Oh, why something so big? Okay, first group is here. The midpoint is actually between 38 and 40. Yeah, right here, 38 and 40. So between them is 39. Okay, so your Q1 is 39. First quartile is 39. Okay, then you look at the second half of your group. Second half of group is here. Then the middle is actually between 51 and 52. Right, so Q3 is 51, 52. Between them is 51.5. Okay, so your IQR, interquartile range, is just the difference between these two. This is 12.5. Okay. Question 16A. Examiner's report. This was one of the most challenging questions on the paper with a significant number of candidates finding the range rather than interquartile range. Again, it's a very, very flowery way to say that a lot of students suck at this. Okay, part B. 2 packets are chosen at random. Find the probability that one packet has a mass more than 50 grams and the other packet has a mass less than 50 grams. Wow. See, this question was generally well answered. Interesting. I find part B conceptually more challenging than part A. Anyway, okay, where are the packets that's less than 50? It's here. Let me just highlight it in green. Less than 50 here. More than 50 is the yellow color one. Okay, so the probability of getting one more than 50 and the other one less than 50 is I get more than 50 first, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9, sorry. So less than 50 is 9 out of 13. Okay, after that, I draw the one that's more than 50, so it's 8 out of 12. Again, there's no replacement. I understood from the question, no replacement. Okay, now this question is one of the tricky ones in probability, is that because the order does not matter, right? So we can also draw the one that is more than 50 first. And then we draw the one that's less than 50. Just 9 out of 12. Okay. Oh, this adds. It's plus. Okay, so okay, usually we can type calculator, but this one no calc. Okay, so to do your multiplication of fraction, look across diagonally first, see if you can simplify. So 13 and 8 cannot simplify. Leave it. Okay, 9 and 12 can simplify. So this divide by 3, this one divide by 3. So we do, after that, 3 times 8 over 13 times 4. 3 times 8 is 24. 13 times 4 is 52. Yeah. Is it 50? Wait. 3 times 8. Oh, wait. 8 and 4 can simplify further. Hang on. Anyway, I just continue from here. So 24 and 52. The second multiplication is also 24 and 52. Okay, just add them up. This is 48 over 52. Okay, interestingly, if you did not leave it in the simplest fraction, you won't get penalized. Yeah, let me check. Yeah. You won't get penalized. So, but a good habit is to simplify lah, huh? So both of them are even numbers. They can actually be divided by 4. So this would be 12 out of 13. Is it 12 out of 13? Wait, I'm tripping. Hang on, let me do it again. Let me. Okay, sorry, 9 out of 13 times 4 out of 12 plus, oh, I screwed up, yeah, 4 out of 13 times 9 out of 12. Okay, then can simplify again. 4 and 12 can simplify, 9 and 3 can simplify. So it's 3 out of 13. 3 out of 13. This one's also, the second one is also same, plus 3 out of 13 is 6 out of 13. Okay, so 6 out of 13. Okay, that's the answer, by the way. I got it wrong for my first calculation. Even your teachers cannot get full marks sometimes. I would have just left it there, by the way. Okay, let's move on. Okay, a lot of my students actually struggle with this. Okay, let me go through this. 0.2a recurring. How do you change 0.28 recurring to a fraction? Okay, those of you who actually learn the method who have applied it. So the trick is we let x be 0.28888888 recurring. We want to eliminate your 8s. Okay, so I'm going to times 10 to this. 2.888888. Okay, then we find the difference. Right, so 9x is this whole thing minus this whole thing. So you realize that the 8s behind all cancel out. So it's basically just 2.8 minus 0.2, which is 2.6. Okay, then to find x, I divide 2.6 over 9. I cannot have decimals on top of fractions. So what I'm going to do is just times 10 to get rid of my decimals. It's 26 out of 90. Okay, so 5 out of 9 plus 0.28 recurring is the same as 5 out of 9 plus 26 out of 90. I just need to make my denominator the same. 50 over 90 plus 26 over 90. And then just add 76 over 90. Okay, now for this, you need to simplify. If you don't simplify, you won't get full marks. Okay, you have to simplify. So in general, always simplify your fraction. It's a habit to remind yourself, always simplify a fraction. These are both even numbers, so I can divide by 2. 3845. Okay, I think that's the most simplest form already. Okay, so this one, if you're still not familiar, please revise how you convert recurring decimals into fraction. Okay, question 18, a lot of students finding also. Now take this as an official warning for those of you who refuse to memorize the special angle for trigo. This is the time for you to memorize it. Okay, I cannot say this, I cannot stress this enough. I've told all my students to memorize the special angles. They're like, screw it. I'm going to give it to you all here. So special angle 0, 30, 45, 60, 90. Sine 0 is 0, sine 30 is half, sine 45 is root 2 over 2, sine 30 is root 3 over 2, sine 90 is 1. Cosine and sine just flip. Okay, you just flip the order. Tangent is the one that needs a bit of work. This is 0, this is 1 over root 3, this is 1, this is root 3, this is infinite. Please memorize. Now, very easy memorize one. 1, 2, 3. Right? That's it. Now, if you don't memorize, there's no way in hell that you can do question 18. And you're going to lose a lot of marks. Okay, let's see what the examiner's report says. For those candidates who knew the exact value of cosine 60, this question was answered well. A small number of candidates chose blah, 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 blah. Okay. So if you don't remember, that's it. You don't memorize, you're done. Okay, in the quadrilateral, ABCD is formed by two right angle triangles, ABE and BCD. Show that CD equals 10. Where's CD? CD is here. Okay, to find this length, I need this length and this length to use Pythagoras theorem to figure out the length of CD. So to find the length of BC, this one here, I need to find the length of AB first. Okay, so to find the length of AB, I need to use trigo. Okay, I have hypotenuse. Let me just redraw this. Take a look at this right angle triangle here. I have the hypotenuse. I need to find the adjacent. Ka, right? Tua, ka, so. Again, if you all don't memorize this, GG. Okay, cosine 60 is AB over 18. Okay, so AB is 18 times cosine 60. Cosine 60 is half. Need to memorize, so it's 9 cm. Okay, then we can find the length of BC. 70 minus 9, AC. Okay, then to find DC, we can apply Pythagoras theorem. 6 squared plus 8 squared. Again, this is a Pythagorean triplet. 6 squared, 8 squared is actually 10. Okay, next, find the perimeter of the quadrilateral, giving your answer in the form P plus K square of Q. Okay, to find perimeter of any shape, there's only one way to do it, is just to add up all the sides. Okay, so you already have, let me highlight the sides that we already have. We already have this one, we have this one. We already found this one here, this is 10. So what we really need is this side here, ED. Okay, to find ED, we can use Pythagoras, we can also use trigo. Okay, so to find ED, we need this length of EB. Okay, and we already know AB is 9, so two ways. Method one, we use Pythagoras. So BE is 18 square minus 9 square. Okay, this one a bit more tedious. So 18 square, we have to do it manually. 864，844，8，423。Okay, and then minus 81. It's 3 square root 233. Okay, then we need to simplify square root 233. Wait, is it 233? Oh no, 243. There is something weird with 233. 243. Okay, so one disadvantage here is you actually need to simplify 243. So you need to actually know how to break it down. So to break it down, 243 let's divide by 3. I'm prime factorizing, by the way. So 243 divide 3, 81, 3. Oh, this is actually 3 to the power 4. Wait, is it 3 to the power 4? No, 3 to the power 5. Okay, so if you do your prime factorization, you get 3 to the power 5. So the square root of 3 to the power 5 is actually 9 square root 3. Okay, so if you choose Pythagoras, this is your number sense needs to be really, really strong to simplify your sets. Okay, so is there a faster method? Yes, we use trigo. But if you want to use trigo, you need to memorize your special angles. Okay, so BE is the opposite side. You have the hypotenuse. In fact, you also have the adjacent, so you can use any trigo function you want. I'm going to use sine. So sine 60 degrees is opposite, so EB over hypotenuse 18. So BE is 18 sine 60. Sine 60 is root 3 over 2. Cancel. This is 9 root 3. So look, a bit faster. Okay, now we don't want EB, we only want ED. So ED, right here, is 9 root 3 minus 6, which is 3 root 3. Hey, sorry, it's just that, it's just that. Okay, so the perimeter is 18 plus 17 plus 10 plus 9 root 3 minus 6. Then we just evaluate this. 35, 45, 45 minus 6 is 39. So it's 39 plus 9 root 3. Okay, this one's 4 marks. The sad news is this is actually quite close to AdMath-ish question really. Okay, AdMath is not that easy, but it's quite close to that really. Okay, let's move on. Question 19, in the Venn diagram, shade the region A union B union C complement. Okay, so we just shade in A union B union C first. A union B union C is everything here. Okay, complement just means I don't want anything that I shaded. So I take everything else that I did not shade. So everything outside here. Okay, okay, there we go. So that's it. 1 mark, free. Okay, simplify certs. Okay, certs, confirm will come out for paper 2, no matter what you're doing. They ask you to simplify, they ask you to rationalize. So this one definitely come up. Spend some effort to practice. Okay, simplify square root 300 plus square root 48. So I'm going to prime factorize this first. 300 to 150 to 75, 5, 25, 5, 5. So 300, I can write it as 2 square times 5 cube. Okay, now to simplify squares, right? To simplify square roots, you want to express it as in groups of squares as much as possible. So this is actually 2 square times 5 square times 5. So I want to isolate as many squares out as I can. Okay, so square root of the 300 is 2 squared times 5 squared times 5. So any squares you can just take out. So it's 2 times 5, 10, 5 remain. Okay, so square root 300 is 10 times root 5. Is it 10 times root 5? Wait, I think I did something wrong. Oops, wait. No, correct. Wait. I factorized wrongly already. Yeah. Okay, 5. This is 15 actually. 3, 5. Okay, so 300 is 2 square times 5 square times 3. So when I square root 2 square times 5 square times 3, all the squares I can take out. So I can take out 2, I can take out 5, and it becomes 2 times 5. So 10 root 3. So same thing with 48. Okay, 48 is 2 to the power 4 times 3. So 48, I can write it as 2 square times 2 square times 3. Again, I try to split out as many squares as I can. Okay, then I take out 2, and I take out 2, that's 4. So 4 root 3. Okay, so I add them up. This is just 14 root 3. Okay, rationalizing denominator is pretty straightforward, and it's usually it's really just 3 marks. Okay, I multiply this with the conjugate cert, which is 2 minus root 7. Okay, what I'm doing here, just a bit of concept recap. I'll talk a lot already, is we're using the difference between 2 squares. A plus B times A minus B equals A square minus B square. So if A and B are certs, right, I'll be squaring it and it'll be gone. So that's the whole concept of rationalizing your denominator. Okay, so if it's plus here, you multiply by minus. Okay, that's your conjugate cert. Okay, then I'll just do my working. 9 times 2 minus root 7. Okay, 2 plus root 7 times 2 minus root 7. Okay, the top I keep it factorized first. In fact, you can keep your final answer factorized. Okay, then the bottom is just a plus b times a minus b. So when I expand this, it will be a squared minus b squared. So 2 squared minus root 7 squared. This is 4 minus 7. 4 minus 7 is negative 3. Okay, then I can simplify. This is 3. So my final answer is negative 3, 2 minus root 7. Okay, you can leave it like that. Okay, or you can expand it if you want. Either way. Okay, let's move on. Okay, perpendicular bisector. Again, every year, this tends to come out every year, this sort of questions. So just prepare your coordinate geometry. Okay, write down coordinates where the graph crosses the y-axis. When a line crosses the y-axis, your x equals 0. Okay. Similarly, when you want to find your x-intercept, if you want to find where the line crosses the x-axis, you let y equals 0. Okay, so when x equals 0, we just substitute this 0, y equals negative 3. Okay, this should be 3 marks. Okay, part B, find the equation of the perpendicular bisector of line AB. Perpendicular bisector. Okay, I sketch this out first. Okay, find perpendicular bisector, you need to find the midpoint of the points first. So find the midpoint. 1 plus 5, 2, 7 plus 15 divided by 2. So this is 3, 11. Here's a midpoint here. Okay, next, you need to find the gradient of your line. Oh, I missed this part. Basically, if you want to find equation of straight line, you need two things. One, you need its gradient. Second, you need any point on that line. Okay, so we already have this. We already figured it out. That's the midpoint. So the line that you want to find passes through the midpoint of AB. Next thing you need to do is find its gradient. Okay, to find the gradient of the blue color line, you need to first find the gradient of the red color line, AB. So MEB is y1 minus y2, x1 minus x2. Remember, your y is on top. If you flip this, I don't know what I say. Okay, y must be on top. So 8 over 4 is 2. Okay, the gradient of two perpendicular lines, if you multiply them together, it will be negative 4. Okay, so the gradient of your perpendicular bisector will be negative half. It's just taking the negative reciprocal of your gradient. See? So if it's 2, you take negative 2 and you flip. Okay, then you have the gradient already. Next, you construct your equation. So one way to do it is just you let it y equals half x plus c. And it passes through this point, right? So when x equals 3, y equals 11. No calculator, so need to do this manually. So c is 11 plus 3 over 2, which is 22 over 2 plus 3 over 2, 25 over 2. Okay, so your equation is y equals negative half x plus 25 over 2. Okay, let's move on. 32. Okay, when you see keywords like this, stationary point, immediately in your head should ring dy dx. Okay, this curve has an equation, stationary point here. So we just find our derivative first. Okay, so to differentiate, you bring down the power and reduce the power by half, by 1, sorry. Okay, okay, so at the stationary point, dy dx equals 0. This is the concept. Stationary point or turning point. Sometimes they'll say turning point. Stationary point, turning point, your gradient function equals 0. So we let this be 0. Okay, then we just solve a quadratic equation. factorize. So in your non-calc paper, any quadratic equation can be factorized. If they ask you to solve, can be factorized. Okay, unless you're doing completing the square. Then that one different story. Okay, I'm going to factorize this first. Okay, negative x, 3x. Okay, so this is 3x minus 1. X plus 1 equals 0. Okay, solve x equals negative 1 or 1/3. Okay, this one is already given to you here. So the other turning point is this one. So there's only the x coordinate. You need to find the y coordinate. So how do you do? What you do next, you substitute this back into your original equation here. Okay, so when x equals negative 1, y equals negative 1 cube plus negative 1 square minus negative 1. So I suggest you actually write out the substitution. Do not do the substitution here because you're prone to make careless mistakes. Okay, negative 1 cube is negative 1. Negative 1 square is 1. Negative minus 1 is just plus 1. So this is 1. So your coordinates is negative 1, 1. And okay, this 5 marks is pretty generous because it's pretty simple only. Okay, let's move on. Okay, by sketching the curve, determine whether the stationary point on third negative 5/27 is maximum or minimum. Okay, this one need to sort of remember. For cubic curve, it either looks like this or like this. Okay, if the coefficient of x cubed is positive, it starts, it will end positive. Just think of it that way, it will end outwards. You end with a smiling face. If it's negative, you end with a frowning face. Okay, so positive, you end positive. So your curve will look something like this. Okay, just a sketch will do. They will just give you mark for the shape. So let's say if your curve is slightly to the right or slightly to the left like this, you still get marks. Okay, but you have to make sure that your turning points are correct. Okay, because your first turning point is one is positive, the other was negative. So your turning point needs to be in the right quadrant. Okay, so you cannot draw a little too off, basically. Okay, so this is acceptable, but just FYI, it actually crosses the origin here. So the actual curve crosses the origin, looks like this. Okay, so determine whether 1, 3, negative 5/27 is maximum or minimum. Well, it's a minimum. Okay, just based on the sketch. Okay, part C is the thinking skill question. I think most students did not get this right. Let me check the examiner's report. Yeah, part C, they say this question was the most challenging question on the paper. Okay, it's also a very MF-ish question, so it's a bit unfair, but it's only 2 marks. It's put there to separate the full markers from the A, A stars. Okay, so here's the concept. The equation has fewer than 3 solutions. So this equation, I actually can break them up into 2 simultaneous equations, by the way. So this one I can break it up into y equals x cubed plus x squared minus x and y equals k. So the solution to this equation, right, is actually the solution to this pair of simultaneous equation. Okay, graphically, what it means is the solution is the point of intersection between this curve and this line. I repeat, graphically, the solution is the point of intersection between this curve and this line. Okay, you have already sketched this curve. Right here, assuming you did correctly. Okay, so what you need is to analyze with y equals k. Y equals k is actually a horizontal line. Okay, so let me just put in the horizontal line. Use pink. Let me use black. Okay, horizontal line here. Okay, so depending on what k is, your line can actually go up and down. So if k is a big value, the k will go up. I cannot move my k. Oh, why can't I move my? Okay, so it can go up, it can go down, it can go up, it can go down. So varying k would vary where this line is. Okay, here, oops, here. So I want this to have fewer than 3 solutions. So notice that, let's say if your line is here, it will cross your curve at 3 points. 1, 1, 2, 3. So at this portion, you have 3 solutions. You don't want that. Okay, so what can you do? You can actually move the curve downwards a bit. Move it down, move it down, move it down. So at this point, you only have one solution because the line only crosses the curve at one point. Okay, and if it's here, let me move this. If it's exactly here, if it passes through your meeting point, it will have exactly 2 solutions. Right? So the region in which you have fewer than 3 solutions, so here is exactly 2. If it goes any higher, it will cross at 3 points. Okay, so one region is when your k is less than -5/25. It needs to be below or touching your minimum point. Okay, the other region is when this line, again, same idea, is when it's just touching the maximum point, you will have exactly 2 solutions. Any higher, you have only one solution. So the other region where you only have 2 or 1 solution is when k is higher than your maximum point. So that's the answer. That's why I need 2 marks. 1 mark for this, 1 mark for this. So the answer is actually k less than -5/27 or k greater than 1. It's a very MF-ish question. Yeah. So again, it's okay if you don't know how to do this, because if you just throw these 2 marks, you still get 98. That's still an A star. Okay. Yeah, that's what I tell my students lah. Okay, let's move on. I think this is the last question. Last question, 3 marks, by the way, indices. Okay, simplify x squared over 4 to the power of 3/2. Okay, so I write it bigger. Okay, so what I'm gonna do is just gonna apply the 3/2 to this and this. Okay, powers like this, right? You just multiply in. So top will be x cubed. Okay, 3/2, 4 to the power 3/2. The denominator is your power of your root. So this is actually square root of 4. This is your power, so cube. Root 4 is 2, 2 cubed is 8. So this is just x cubed over 8. Just like that, 2 marks. If you have done your indices question, it's actually pretty simple. Okay, part B, find the value of x. When you're solving equations involving indices, make the base the same. Okay, extended, this is the only way. If you do MF, there's another way, you need to use logarithm. But for extended, this is the only way to do. Make the base the same. So observe 16, 1/2, 4, they all have the same base of 2. You can make them base 2. 16x, 16 is 2 to the power 4. So this 2 to the power 4x. Half is actually 2 to the power of -1. So times 2 to the power of -1 to the power of x. 4 is 2 squared. 2 squared to the power of x plus 3. Okay, then expand everything. 2 to the power of 4x times 2 to the power of -x equals 2 to the power of 2x plus 6. Common mistake here, you all forget to expand again. Okay, if same base, you can actually combine your index. So this one is just this plus this. So this is 2 to the power of 3x equals 2 to the power of 2x plus 6. Once the base is the same, the index needs to be the same. So 3x equals 2x plus 6. Here you're just solving a linear equation, x equals 6. Just like that, 4 marks. Free. Okay, so just a quick recap for this paper. Right, some things that you all need to work on is 1. Let me just go back up. Just a quick analysis of what kinds of things that keep popping up. Okay, for this paper, non-cut paper, you need to make sure that 1, that your basic operations with fraction and decimals is okay. Sorry, not just okay, it's strong. Okay, if you know that these are not strong, go and practice. Okay, take worksheet from me, just drill them. Okay, second, this is a wake-up call for those students who just so arrogant, so cocky to not memorize the trigo functions. memorize your special trigo function. Okay, third, if you notice this paper, a lot of algebra. Basic algebra, factorization, linear expression, inequalities, algebra need to go and revise. Okay. Now the first half of the paper, the first 6 questions, or 5 out of 6 questions is all primary question, right? Time, decimal, simple operation, all the stuff need to go and memorize. Not memorize, go and practice. Okay. Fourth, recurring decimal. Recurring decimal has always come out, but this time, because you do have calculator, is even more alarming, right? If you are not confident, again, go and practice. Okay. Fifth is your percentages. Okay, percentages and stats. Now this doesn't change. Like, it's not anything new. Percentages and stats have been like a very big thing for IGs ever, like for quite a long time. So the kind of the new thing that you need to take note of is, one, your basic operations with fractions and decimals need to be strong. Second, go and memorize your trigo, special trigo values. Okay, third, recurring decimals, go and revise. Right. Oh, and one more thing. For the new syllabus, all syllabus don't have this issue. One more thing is your certs. Certs need to go and remember, practice until you are like, you can do it with both eyes closed. Okay. So these are the new things that you all need to take note of with the new syllabus, because you don't have calculator, and then the syllabus also have like new things. They also take away some stuff. Okay. So go and practice this. Make sure you're very strong. Okay, algebra includes like indices, fraction, indices as well. So you see the last part, they give you like what, 6 marks. But it's also, it's just very easy only. Yeah, certs need to also go and practice a lot, because it will pop up in Pythagoras, it also pop up in Trigo. Okay. Yeah, so this is the review. This is like the longest review I ever made, because it's a new syllabus and it's no calculator, a lot of new content as well. Okay, any questions, please text me. If you need more practice, also text me, get it from me. Okay.